Well, we have reached the end of Chapter 6, our unit on the applications of integration. We have saved maybe the easiest for the last. So we're looking at the average value of a function. So it's very straightforward, as you can imagine. If you've got some function and it's doing something like that, and we want to find, well, what is its average? We simply find the accumulated area underneath it and divide by the width of our boundaries here, and we'll get a flat rate that's the equivalent amount of area. So here's a simple example. We've got a cubic function. I've graphed it here, and we're going to find the average value from 0 to 10. It's a pretty straightforward, easily pictured cubic function. Well, we're going to take the integral then over the range of our boundaries from 0 to 10, and then we're going to average that. So we've got to put our 1/10 out front. I'd begun doing this when the phone rang, so I'm starting over. Finding the integral of this, we're just going from a 3rd degree up to a 4th degree. And I've just, I hope, done it correctly. You can check. I think I'm good to go. There's 1/10 out front, and then it's from 0 to 10. Okay, so it's simply a matter of evaluating this. We plug in this, and we've got 4 zeros over 120 x, oops, sorry, I've gotten rid of that, minus, and then 4 with 3 zeros over 30, and 100 over 2, and that's a plus, and then plus 30, and all of this times 1/10. So we'll get rid of some zeros. There's 0 gone, and there's a 0 gone, there's a 0, and there's a 0. There's the 1, and there's that. So I have did I have enough zeros there? 1, 2, 3, 4. I thought that was wrong. So there is actually 100 zeros. I thought that was looking too small. I would have wound up with a negative, so I need that. So 100 divided by 12 is 8 1/3, minus then 40 divided by 3 is going to be 13 1/3, and then this is 5 plus 3. Okay, 5 plus 3 is 8. 8 plus 8 is 16. 16 1/3 minus 13 1/3 gives me an average value of 3. All right, so we could then go to our calculator here and go back and see if that seems like a sensible answer. If I go down here and type in 3 and graph that, does it look like the areas above added to the area below? I think that's about equal. And so there we go. Sometimes you're asked to find an actual place in the function that has the average value. In this case, we got lucky, or it's a little bit contrived maybe, but there is the average value. So it would be when the function first starts at f of 0. We could also then, because of that, if we wanted to find another one, we could factor out an x and put it into a quadratic formula. And it looks like it's going to be around 8 and I don't know, maybe 3 and something. Okay, so that's one. Another example from the real world is perhaps found by using the fact that the temperature during the day is going to oscillate. It could be a sine or cosine function. So here we've got some temperature that's modeled by this simple function. Starting at 9 in the morning, see what the average temperature is over the next 12 hours. It's probably warming up, so we expect it to be not just a net of 0. So I'm going to find the integral then and take 1/12 of that because it's over 12 hours. Our units are in hours. Pay attention to whether it might be minutes or something. Don't get confused. From 0 to 12 then, don't go 9 to 9, 9 a.m. to 9 p.m. They would have to adjust the equation if they wanted that to happen. 50 then plus 14 sine of pi over 12 times t dt, and then this becomes 1/12 50t, and then the integral of the sine is the minus cosine, so it's going to be minus, and I'm going to keep this as 14, and then I'm going to take the derivative of the inside because of the chain rule here, or I integrate with the chain rule in mind, I should say. So that's going to be 12 over pi, and I'm going to keep that like that rather than multiply it out, and that's then the cosine of pi over 12t, and that is from 0 to 12. All right? So when I evaluate that, then I get 1/12, and 50 times 12 is 600, and minus then, I'm going to keep that as 14 times 12 over pi, because I usually get some cancellation. When I plug 12 in, the 12's cancel, so it's cosine of pi. Cosine of pi is 1. Careful, cosine of pi is -1, because you're going halfway around the unit circle, so it's -1. And then I'm going to subtract. When I plug in 0, that goes away, but it's then minus 14 times 12 over pi, and when I plug in 0, cosine of 0, that is 1. And what this gives me then is 1/12, and that is going to be 600. Well, actually, let's get the 1/12 in there. If I put the 1/12 back in, too late now for that, but the 1/12 here will cancel with that and cancel with that. So it's minus 14 over pi with the -1, so that's plus, and then this is minus a minus, so this is plus, and then that gives me 600 divided by 12 is going to be my 50 plus 28 over pi. Okay, so that would be your answer. Pretty straightforward. Hope that gets you started. Good luck.